Okay guys, in this video we're going to be looking at primarily writing the standard form of the equation of a parabola with given characteristics. And so in order to do this we're going to be or want to be very familiar with the standard form of the equation of a parabola. And you'll notice that I have both forms written down here depending upon whether or not you'd have a vertically oriented parabola or axis or a horizontally oriented parabola or axis. But to revisit very quickly, with a vertically oriented axis we would have some type of parabola where the axis runs north-south here, and the vertex would be somewhere on this parabola. So given that this is my vertex here, say for instance it opens upward, something like this here, this would be an instance of the very first type of equation here where we're squaring the x term. Now in terms of its parts, there are some other parts that we want to make sure we put on here, but one of them is the focus. Recall that the focus is this point here that anything coming in parallel to the axis, everything bounces back in towards. But this focal point here is said to be a distance of p units away from the vertex. So p is our directed distance, and it's the directed distance from the vertex to the focus. And that being said, the other part of this parabola we want to kind of identify is also this line that is perpendicular to the axis, and we refer to this as the directrix. So revisiting the definition of a parabola, that is to say that it's the collection of all points that are the same distance from the focus as they are from the directrix, that would mean that every point on the parabola having to be the same distance from the focus as it is to the directrix kind of implies that the vertex is the midpoint of the focus in the directrix as well, and that we would have to go p units just the other way in order to get to your directrix. So identifying these parts here, the only thing that would be different in a horizontal sense would be that your axis would run horizontally. You would have some vertex on here and it could open either left or right. I'm going to have this one open right, but in this particular case we'd say that there would be some focal point here that is p units away from the vertex, and that p units back the other way perpendicular to our axis is our directrix. And so we're going to put this here. So looking at these examples we see up here where we're asked to write the equation, we're going to have to pick the appropriate form, but also just to point this out here, we're really going to want to come up with h and k as well as p. And those are really going to be the values that we need to look for when we write the equation. So really quickly here, let's also revisit what h and k represent. We say that the point h and k is the vertex location. Okay. So knowing these things, let's go ahead and take a look at writing these equations here. And one thing that I would just beg you to do is just draw a picture. So it's understood that on 8 and 10 here, the vertex is given to be at the origin of the xy coordinate plane. So the very first thing I'm going to do is I'm just going to draw in what I see. And I know that the vertex is at 0, 0. So I'm going to write down here, we say vertex is at 0, 0. And we know the focus is at 0, a half. And so if this is 1 right here, I could imagine that my focal point then would be right here. And I'm going to label both of these. So we have 0, 0, 0, a half. Now from here, what are some things that we would already be able to tell about this? Well, because the focus and the vertex lie on the axis of the parabola, we know then that the axis of this parabola must run north and south or up and down. And so I'm going to go ahead and label this axis here, x equals 0. We don't need to come up with the axis on this particular problem, but I am going to list it here. But the other part of this is I know the distance it takes me to get from the vertex to this point here that we're calling the focal point. So if that distance is a half and we go up by a half, then p is a positive a half here. And with respect to h and k are always our vertex values here. And so maybe not a bad idea, but maybe I write out here h, k, and p are the three things I need to know to write this equation. We know that h and k are both 0 and 0 because this is centered or vertexed at the origin, but also we can see here just by observation that p is a half a unit and it's a positive a half. And so looking at what we have here, suppose we would have some parabola that would open up this way. I'm not drawing the rest of it just because I have all the values I need. Let's go ahead and set up our equation. So with respect to our equation, it looks like we have a spot here. Because we have a vertically oriented axis, we're going to have this form here where our thing being squared on the left is the x term. And so we're going to write this as x, now minus 0 or minus h squared equals 4 times in parentheses p, which we observed to be a half, times this would be the y minus k part, which in this case k is 0. So to clean this up, I would say that the ultimately final form of this would be 4 times a half would be 2, y minus 0 is 2, sorry, y minus 0 is y. So we get x squared equals 2y would be the equation of this parabola here. Taking a look at number 10. Let's consider this. We still have our vertex at the origin. That's a given part of this problem here. So I'm going to mark this. And again, what we're going to know then by knowing the vertex is we're going to have the values of h and k. So we say h equals 0, k equals 0. We just need our p value. Now with respect to p, p is the distance from this vertex to the focal point. But see, we weren't given the focal point here, but instead the directrix. So the directrix, y equals 1. Let's go ahead and start by graphing that. That is a horizontal line at a height of 1. We just put a dotted line through this. And I'm going to label it y equals 1. The thing about this, though, is this vertex point has to be the same distance from the directrix as it is to the focus. And because also the axis, which the focus lies on, runs perpendicular to the directrix, we know that the focal point must lie the same distance away from the vertex as the directrix does, but in the other direction. And so that means that our focal point would have to lie 1 unit down if our directrix is 1 unit up. So I'm going to go ahead and label this focal point here, but this would be the point 0, negative 1. That being said, we are really looking for p, and the fact is, in this case, p is negative 1 because we go down 1. So now that I have all three of my values I need, we're going to choose the appropriate form of this equation, and I see here that because my vertex is here and my focus is here and my axis therefore is vertical, we're still going to use the first form of this equation. And so we would get x minus h, which in this case is 0, squared equals 4 times p, p is negative 1, and then we get y minus k, which is 0. So again, I'm going to clean this up. We're going to put the simplified form of this here. We say x squared equals negative 4y. And this thing would be the equation of this parabola here. So that's a couple of examples where we look at things centered at the origin or vertex at the origin. Let's look at a couple of examples where we don't necessarily know that the vertex is at the origin. We know it's somewhere else. And so number 12 here, we're going to take a look at this situation. We're going to say write the equation. Well, our vertex is at 4, 3 and our focus is at 6, 3. So the name of the game here is going to be, if you don't draw a picture, you're going to probably get a lot of these wrong. So let's go ahead and start by drawing a picture. We would say 4 to the right, but 3 up. That would be right here, and we could label this. We say this is 4, 3, and this is our vertex. With respect to the focus, we say 6, 3, so that's 3 more units to the right here. I'm going to say that this is our focus, and this is 6, 3. But instantly, what I'm able to tell from this is because my vertex and focus always lie on the axis of this parabola must run left to right here. And so we're going to label this. We say y equals 3 is the equation of our axis here. At the same time, if I go 3 units to get to my focus, and I'm going in the direction of going to the right, or the rightward direction, we're going to say that p is a positive 3 here. So already with what I know, the fact that I know that the vertex is at 4, 3 leads me to the fact that I know what h and k are. They are 4 and 3 respectively. And with respect to the picture we drew here, we were able to deduce what the p-value is just by visually confirming it. We get 3 here. So isolating these values, or kind of making sure that we have them here. Let's write the equation. Because this is a parabola that opens to the right here and runs sideways, we're going to choose a form of this equation that is starting with y being the squared term. And we say y minus what? Now, is this y minus 4 or y minus 3? The important thing here is that y is always bundled with k. So we really get y minus 3 squared. On the right side, we'd have 4 times p. So I'm going to put p in parentheses here. P is 3. And then this is times x minus h, where in this case h is 4. So this would be our equation right here. We certainly do want to clean it up if possible, and in this case we can. We say y minus 3 squared equals 12, x minus 4. And from here, we could tell things like it does open sideways because y is squared. We know that our h and our k are 4 and 3 respectively, and because 4p equals this, p must be 3. So look at number 14 with me now. We'll take a look at what we know here. So in this case, let's go ahead and sketch out what we're told. We are told that the focus is at 2, 2. So 2, 2 we can visualize as being right here, and I'm going to label this focal point, focus, 2, 2. But the directrix is y equals 1. Now with respect to y equals 1, that's a horizontal line running through this xy coordinate plane at a height of 1. So the reason why we're doing this is to kind of get a visual of what we would be able to tell from what we're given. I already know that because this is my focus and that my directrix runs left and right, I know that the axis has to run through my focus, and also at the same time it has to be perpendicular to this directrix here. So I'm going to say that this must be x equals 2, but at the same time, from the focus to get to the directrix, we had to go 1 unit down. And so that means that if the vertex is the midpoint of the directrix in the focus, it's the same distance from the focus as it is to the directrix, it means that our vertex actually has to be this midway point between our directrix and the focal point. So if we said, well, what would this point be? Halfway below 2 would be 1.5. We could say this is 2, 1.5. Or we could say halfway above a height of 1 and still call this 2, 1.5. The point of being able to tell this right here, besides just being able to graph it, is the fact that we needed to know P. And so P in this case looks like from the vertex to the focus I have to go up by a half. I'm going to call this positive a half. It looks like we know the vertex, and so we know H and K. The vertex is at 2, 1.5, and then our P value is a half here. Let's go ahead and build our equation. Now this is a vertically oriented equation, so the very first thing we're going to do is start with x being squared. We're going to say x minus h equals 4 times P, so 4 times a half, times y minus k, and in this case our k is 1.5. And so cleaning this up, we get x minus 2 squared equals 4 times a half, which is 2, times y minus 1.5. And we can see that this would be a parabola that has its vertex at 2, 1.5 and opens upward because we have a positive p value here. 4p equals 2, then p must be positive. Cheers.